Okay, this lesson is on graphing inequalities. We're going to work with both slope-intercept form and standard form. So when you look at these two problems that we're going to do first, you should notice that the only difference between them is we have a greater than and we have a less than. So in this first example, we see that we're written in the form y equals mx plus b, which is slope-intercept form. So our m is 2/3 and our b is -1. So we're just pulling that right from the equation. Now our inequality is greater than, and because we're not equal to, we're strictly greater than, we're going to use a dashed line for our boundary. So to graph, I'm going to go to -1 as my y-intercept, and then I'm going to graph up 2 to the right 3, up 2 to the right 3. And I can also go down 2 and left 3, down 2, left 3, and down 2, left 3. And I'm going to use a dashed line to connect this. Now, since my inequality symbol was greater than, I'm going to shade above. So that means that all of the ordered pairs that are in this yellow shaded area are solutions to my inequality. So let's talk about a couple solutions. My favorite one to always test out and talk about is 0, 0. So I can see 0, 0s in my shaded area. So, oops, didn't really mean to write up there. Okay, so let's talk about 0, 0. Let's substitute that back into the original equation. This is x, this is y. Is 0 greater than 2/3 times 0 minus 1? Is 0 greater than 2/3 times 0? That's 0. Is 0 greater than -1? It sure is. Let's pick some random point. There. So that's -5, +2. -5, +2. Okay, this should be a solution. X, y. Y is greater than 2/3 x minus 1. All right, 2/3 of -5. So 2 times -5 is -10, -10/3. Getting a common denominator, that's -13/3. Well, obviously, this is a positive number, so 2 is definitely greater than this negative number. No doubt about it. So let's look at something that's not a solution. So let's pick something that's not shaded. There. So that's 1, 2, 3, -2. 3, -2. This shouldn't work. Okay. Y is greater than 2/3 x minus 1. 2/3 times 3 is 2. So is -2 bigger than 1? Nope. And it shouldn't be because that's not in my shaded area. So let's look at this one. How's it different? Well, my slope's the same, my y-intercept's the same, but I'm less this time. My boundary line is still a dashed or dotted line because we're not equal to, we're just less than. So I'm going to graph essentially the same way. I'm down here at -1 for my y-intercept, and then I have up 2 to the right 3, up 2 to the right 3. I can even go down and to the left, down and to the left, and a dashed line again. I'm shading less. So all this is my solution set. Even numbers that are even ordered pairs that are beyond what my graph has. So I know that this goes over to +10 and this goes down to -10, but imagine like going over to -20. I'm sorry, that's positive. Going over to +20, +20, 0. Do we think that would be a solution? Well, I mean, this line keeps going up, so yeah, that should be shaded. So let's test it out. This is x, this is y. Is 0 less than 2/3 times 20 minus 1. 2/3 of 20 is 40/3. Getting a common denominator, subtracting 3 over 3. Well, yeah, 0 would be less than a positive number. Let's see something obvious that should work. How about that? 1, 2, 3, 4, 5. That's 5, 0. Let's check that out. 0 is just an easy thing to pick because it's easy to compare to. So if with 5, 0, this is x, this is y. So is 0 less than 2/3 times 5 minus 1? Again, 2/3 times 5 would be 10/3. Subtracting 1 would be subtracting 3/3, so that's 7/3. Yeah, 0 is going to be less than this positive fraction. Let's check out something that doesn't work. Something that's not shaded. How about that? 0, 2. This should not work. This is x, this is y. So is 2 less than 2/3 x minus 1? Well, 2/3 times 0 is 0, so is 2 less than -1? Absolutely not. And that's why it doesn't work. It's not in the shaded area. The only thing that's going to change on these next ones is that I'm going to use a solid line because I am greater than or equal to, and here I am less than or equal to. So 2/3, -1, it's the same exact thing. Up 2 to the right 3, up 2 to the right 3. And I'm just going to use a solid line this time. And shade grader. Ugh. Well, that wasn't a highlighter. Let's try that again. Just wasn't too keen on how that looked. All right, let's try the highlighter. Oh, we do this blue. There we go. So the big difference here is that even numbers that are on my line are going to be solutions. In the last set where it was just a dotted line, we're not going to include anything that's actually on the dotted line. And I'm going to go back and show you that part. So here, oh, dang it. This one's less. So I've got to go less. Okay. So if I actually pick a point that's on my line, like this one, that's 1, 2, 3, 4, 5, 6. 1, 2, 3. That's 6, 3. Okay. So let's see how that works. Is 6, 3 a solution? Two-thirds of 6. So 2 times 6 is 12, divided by 3 is 4. Look what I come out to get. Is 3 greater than or equal to 3? Well, it's equal to, so that works. Same thing here. Let's look at this point. Is that -3, -3? We'll see. -3, -3. Okay. -2 times 3 is -6. -6 divided by 3 is -2. Yup. I get the same thing again. So that works. So not just to say that just these are solutions, anything down here in the shaded region is a solution. And I'm out of time in this video, so I'll talk about why they are not solutions in the next video.